Hi everyone, this is the first video for section 8.3 on multiplying and dividing integers. So like before, we can use the same models and algorithms that we did for whole numbers because the integers are just the set of whole numbers and their opposites are just a set of whole numbers and their opposites. So as long as one factor is positive, we can just use the exact same things that we've done before. So this is what these first few examples are just using this exact same thing, or using the same models that we had before. So if we're looking at 3 times 4, we can think of multiplication as just repeated addition. So we can think of this as just repeated addition. So whenever we do that, we write one copy of our 4 positives. And then we have a second copy of our 4 positives and a third copy of our 4 positives. And then once we have all of that written down, we find the total value. So all of this has a total value of 12 positives. So that tells us that 3 times 4 is 12. So because we just had because we had one positive integer, which is one whole number, one natural number as a factor in this product, we can just write it as using 3 copies. Similarly for part B, now we have 3 times -4, so we just have 3 copies of 4 negatives. So we can do this using repeated subtraction instead of repeated addition. So, well, repeated addition, again, really. Oh, sorry, this is repeated addition. That is correct. It's not repeated subtraction. So this is repeated addition. So we could either do this the exact same way we did part A, where we just have 4 negatives using a sign model, and then just write that 3 times, or we could do this using a number line. So let's do it using a number line. So if we do it using a number line, I'm going to put 0, -1, -2, -3, -4, -5, -6, -7. We're not going to have enough space here. So this is -9. We'll see if we can do it. Nope, we're not going to have enough space. So let me redo this a bit. So if we put 0 here, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. I think we can only fit to -12. Okay, so this is our number line. So we're going to have 3 copies of 4 negatives. So if we start at 0 and we go to -4, let me erase this so we have more space up top. So if we go from 0 to -4 one time, and then we do it again, we repeat this, and we now get to -8. And we do it one more time, and we can get to -12. So this is using repeated addition on a number line. So that we can see that once we go 4 units to the left 3 times, we'll get to -12. So this number line model will tell us that 3 times -4 is -12. So just using this number line model. So I guess this is really a number line model. Okay. And the last one is -3 times 4. So this one's a little bit different than our first two. We cannot have -3 copies of something. So instead, we can rewrite this problem using the commutative property. So this is now 4 times -3. So we have 4 copies of 3 negatives. So just like these first two, we can either represent this using a sign model or a number line model. Either one. So let's just go ahead and do a sign model. So we have 1 copy of 3 negatives, 2 copies of 3 negatives, 3 copies of 3 negatives, and 4 copies of 4 negatives. So when we look at this picture, this has a value of -12 because we have 12 negatives. So that tells us that -3 times 4, which is 4 times -3. This is just -12. Okay, so this is how we can just kind of apply the things that we learned in chapter 3 to doing operations with integers. So we can still use all of these same models, repeated addition, the sign model, the number line model, all of these same things still work. Yeah, so all of these things still work in the case where one of the factors is positive. So one thing all of these had in common was that one factor was positive. We can still think about these operations in the same way that we did before. Just instead of combining copies of positive numbers, we're combining copies of negative numbers. And that all works the same way if we go the opposite direction on a number line or just use a negative sign in our sign model. Yeah, so in the next video, we'll start talking about how we can do modeling whenever both of our factors are negative.